I would now like to pass the presentation over to MLHC Program Chair, Rajesh Ranganath. Go ahead.
Thanks. So to get started, I'd like to introduce Anna, who's one of our panelists here. Anna is a senior scientist in genetics and genome biology at SickKids Research Institute. She's also the Varma Family Chair in Biomedical Informatics and AI and an associate professor in the Department of Computer Science at the University of Toronto. And I'm going to start you off with one of the questions from the audience. So this came up yesterday when we were playing your talk. So the question was, SickKids is a pediatric hospital, and all of the results that you showed might not hold true for general hospitals, where the majority of patients are greater than 50 years old. Do you have any thoughts on that one?
So yes, I have thoughts. Hi everybody, and very happy to be here. So first of all, I think some of the lessons that we've been learning are not specific to pediatrics. The project that we have is about emergency department in a pediatric hospital, but what we've been learning is sort of how to properly evaluate and the parameters to evaluate for deployment that will translate to other hospitals for sure. And frankly, the parameters might be different depending on what policies are implemented at the hospital, which are not necessarily pediatric specific, but really just hospital specific at times. I think the question of diagnostics, the problems that I didn't necessarily talk about for pediatrics are of great interest to me because there is a lot more data for adult applications sometimes than for pediatric hospitals. We've been thinking about how to pre-train models to have better accuracy and then specialize them to pediatrics. Very often we see that it's quite different, that the data is different enough that it does not translate to pediatric hospitals. But going back from pediatric to adult is another issue. So first of all, in some of the domains like radiology domain, if we're talking about kids that are sort of in their late teens, that data is quite similar to adult data. So we think that some of those findings will translate quite well. Some of the diseases are really early pediatrics and they will stop in the adult time. So we don't expect those to translate. So I think right now we are seeing that it's on a case-by-case basis to what will translate back and forth. But hopefully the lessons we are learning in terms of how to deploy models will translate whether it's a pediatric or an adult setting.
Great, thanks. And there's one, excuse me, there's one follow-up related to that question, which is like, now you have this model and it generates some kind of score. How do you ensure that the model will actually be adopted by caregivers? Because integrating into a system is one thing, but use is maybe a step beyond that.
So this is a huge question, right? So to ensure that that the clinicians are on board, all of the examples that we work on, all of the projects that we work on are driven by clinical champions. And I think some of that messaging has come through MLHC for a couple of years now, that clinical champions are incredibly important. And it's really, sorry, 1 second. The clinical champions are helping us in terms of implementation. We also go to request permissions directly with the clinical champions to the senior management or other committees that are needed, security, etc., so that there is a clear need illustrated for the tool. And finally, what we've started doing recently is sort of increasing our messaging to the nursing staff. And it turns out, which machine learners don't often know, is that a lot of these applications will be mostly used by nurses in a lot of cases. It's not just the clinical champion, but the nurses. And so what we've been starting to do is we've been starting to propagate this information to the nurses, having sort of the grand rounds with the nurses and grand rounds and specific scenarios where we talk about what this application does, trying to get the feedback from them about what they think a good implementation for them, a useful implementation for them would look like, and sort of our HCI and the design and the UI is affected by that feedback. And sort of that, we hope, is setting us up for the best implementation.
Great, thanks. I'm going to follow up with one of my own questions with respect to that. It's like, how do you measure the effects? Like, it's not really like a pill. Like when we think about like interventions that you do into a healthcare system, here's like a pill, you can take it, and you like kind of know if it's taken or not. And here there are also effects in terms of compliance. That's one thing we talked about. There may be positive spillover effects, like if there's some cool tool being like, here are the things you need to pay attention to for this patient, you can go tell your friend will know about it, even if they may not be included in whatever like trial you're using to it. So have you thought about how to measure effects and what that might look like?
Yeah, so it's a little bit application specific, but a lot of times, so for example, to be more precise, the emergency department census, where we are measuring the patient volumes and the effectiveness of the tool, we basically are looking at how quickly they can address the patient and how much escalation actually has to happen, right? Because if the escalation, our goal is to try to reduce escalation, to not have to open new units, and it's possible to do if the team is better prepared. So they start discharging earlier, they forecast they have a bigger team on board right away if the volumes are expected to forecast. So that's one example. So we can measure directly in terms of the escalation and the forecast. Right now, actually, we are looking at sort of our forecast of the escalation versus the escalation itself. But we are hoping that in the future, this will not be a proper validation because we will be predicting escalation ahead of time, and it actually won't happen. So that's one thing. Another thing that we are doing is we are looking at reduction of either wait times or, for example, radiological image evaluation times. So we, for example, recently looked at a trial where we ask clinicians to look at an image with and without the mask, and looking at whether or not it reduces the time for evaluation of the image for the particular purpose. So it really depends on the goal, but every time we sort of look at how many, what is the reduction in the undesirable event that we want to prevent or that we want to alleviate. And that's one of the actual evaluations on the ground that we are doing.
You know, some companies have addressed this with randomization in terms of like, you know, if you have an algorithm that's doing something, if it's always doing something, as you said, and you want to make a prediction, you're going to make a prediction based on what that algorithm's influence is on the system. So one way to do it is to like remove it a certain fraction of the times to get like cleaner data. Would that play any role in terms of evaluation in the long term? Or like if like a future algorithm developer, would they have to like correct for the existing algorithm to try to get some kind of idea of what it would look like in the counterfactual world with this new implementation?
So I think this is a little bit up in the air, and everybody's trying to do the best possible thing. We've been studying the effects of what happens, or trying to study the more theoretical setting, the effects of what happens when algorithmic decisions are incorporated into the back into the clinical practice and are affected by that. And the only way for us to sort of try to assess that is trying to ask for the decision before and after they see the method. And I can tell you that a lot of things that are getting implemented, there is no real way to do that. The clinicians actually see the method decision right away and are immediately affected by it. So this becomes sort of a separate trial where we try to assess that, and the situation has to be implemented outside of the gate. So it will be an interesting scenario where the counterfactual is going to be really hard to assess because the outcomes will be completely entangled with systematic decisions.
I'll read one of the comments that we got, which is entertaining. As a pediatrician, I've always believed that adults are just grown children. Comment from a pediatrician in the audience. You know, a lot of the things that you described seem like it takes a lot of effort from just a ton of people. How big are these teams?
It requires a lot of effort from a ton of people right now. What we are trying to do, and I think some of the other hospitals as well, is trying to streamline some of these processes, right? We are just starting out, and so that's why it takes kind of a village. But I would say we usually have 1 or 2 clinicians on a team, maybe sort of 1 or 2 machine learners on a team, and then sort of a design person, and so six-ish people. And it depends also on the modality of the data. So for example, some of the data we can access ourselves, and so we don't require specific systems people, but some of the physiological data that we require streaming in real time requires building a dynamic engine. So we had a much bigger team for that, people with a systems background to build a dynamic engine for the physiological data to be streaming in real time. So these are I don't know if 6 people or 7 people are a bigger team. It again depends on the task, but this is sort of a size and the core of the team, I would say.
What do you think could be made easier? You said that like hospitals are working on making it easier. Could you elaborate on that more?
Yeah, so what we are doing right now, we have this AI in medicine initiative at CKids, which is trying to build sort of easier access and approval pipeline, right? So it's exactly so for example, even in the beginning, we had to go through the regular RIB process for every project. Now, together with the head of the RIB, we have developed a different pipeline for the machine learning projects, where first is the exploratory stage, where we don't have to outline all the variables that will be used because we simply don't know, or there are too many. And so we have the exploratory stage, we have a separate silent trial. So that is sort of a process where we had an AI and ethics specialist that was engaged in setting that up, but now it's a lot faster and more streamlined. The sort of the dynamics of accessing the data in real time is something that we are setting up right now, and so that I think has been set up at for example, a place like Duke and several others, but we're setting that up right now, and so we will have fewer people needed to be engaged to figure out how will it look like, how the ingest will look like real time. So these are some of the things that are sort of technical and require technical teams to build up on a once and maintain, but they will be helpful long term.
So you mentioned review in the data process in terms of like IRB or that kind of thing. What about once like the model has been built, there's some result, there's some like evaluation as well as can be done. Is there another like process by which somebody or some set of people look at it before it's deployed, or is it deployed internally kind of? I don't want to say without oversight, but maybe without anybody else external to the project looking at it again.
So right now, we are closer to the sort of the silent stage deployment. We don't necessarily have things that are like run in real time. At our site, we do have, my colleagues have at an adult hospital, and it's the data access and review happens within a team right now once all the permissions are received. The evaluation of the model and what it can give and provide, I imagine, will be reviewed every so often externally as well. But because we sort of have the stakeholders that are part of the team, otherwise it would just take too long. But since the stakeholders are part of the team, which majority of that evaluation happens within the sort of the broader scope of the team until it's ready, until the model is ready. But I think one, I don't know if that was exactly your question or not, but a tangential question is the data that we see when we train our models versus the data that we see when it comes stream in real time. And that is a day and night sometimes, right? Somehow, either the process has been set up that it pulls multiple times, and these multiple entries for the same patient and for the same encounter actually look different, right? Sometimes they say this patient has been discharged at 10:30. Sometimes they say it was the same patient was discharged at 10:37 or 10:40, and sometimes this is less sort of technical, and sometimes it's more, because if we want to know how many patients there are, it actually changes, that count, and it's probably one or the other, not both. So sort of figuring out how to deal with the noise in the real data due to the epic pools or things like that is a real problem, and something that we are sort of part of something that we are trying to streamline now as well.
Great, thanks. I think we have Yuan Ngiam here.
Yeah, hi Rajesh and Anna. Yeah, well, I've been listening in. Sorry, my video doesn't quite work. It's been really exciting to hear all the developments that are happening. I think we share exactly the same problems. Everything from the difference between retrospective and prospective real-time streaming data to things like validating models and deploying them in practice. So I think I suppose the only thing that we're doing slightly differently is that we don't approach deploying of AI on a project by project basis. Rather, when we look at it, we say that, okay, we build a platform and we can onboard any number of AI projects as long as they pass the post, meaning that they pass certain validation requirements for accuracy and evidence of efficacy. And beyond that, really is about running these AI tools in real time. Currently, we are using a stream-based kind of messaging technology to allow us to quick deploy AI tools in clinical practice and integrate it with our EMR system, which is going to be epic, unfortunately. But yeah, so that's what's going to happen in the coming year, actually. Thank you.
How much effort does it take to deploy with Endeavor AI?
Oh, it's like moving heaven and earth, right? Because you can imagine that it's a production level system which requires a whole team of engineers to kind of build and architect the systems, pass all the security requirements, and also ensure that you provide, tier 1 to 3 level support for tickets or problems that might happen. I'm less involved in that because that's not my area of specialty. Well, I'm mostly involved in the development of the AI tool itself from the clinical perspective and validation perspective. So really it's about bringing it closer to the doctors who will actually use those AI tools. That's my main role, whereas on the back end, the platform is largely deployed by a team of engineers.
Yeah, how hard is it for you as like a user of the platform to push something out? I guess maybe that's more what I was targeting. I was curious.
Yeah, that's a great question, Rajesh, because initially when we started building tools one by one, we very quickly encountered the limit because it's just not scalable. You couldn't deploy multiple AI tools if you wanted, because it's just not feasible for each AI development project team to get all the data, the security, the networking, the connectivity all sorted out on a project-to-project basis. So once you set up the platform, the deployment speed is much higher, right? We're talking about going from anywhere from about 15 to 18 months down all the way to 6 months from start to finish. So, and this is using things like agile methodology to hot sort of develop and deploy these AI technologies. Yeah.
No, thanks. There's a question for the both of you from the audience now is, how are you handling the need to perpetually recalibrate the models? I think you both touched on this quite a bit. But maybe Anna, you can start.
Okay.
Yeah, sure. So depending on the type of a model, so for example, with figuring out the patient volumes in AD, we actually have to recompute every night, and we are monitoring the performance, and we have an idea of the performance sort of bounds that we are expecting, and if we are seeing the sort of the 2 days of validation that we are using, if we are seeing deterioration of that performance, you have to take it offline. Otherwise, it's online and being retrained, or at least that's the plan. For other types of problems where, I don't know, we are detecting hydronephrosis from radiological images, I don't foresee it being retrained very often or redeployed very often. We will continue retraining to see if there is a better performance, but I imagine it'll be closer to sort of versioning as a regular software versioning as opposed to continuous versioning. And I think this really is a property of sort of the expected data shift.
Yeah, absolutely agree with Anna. I think you have to be super careful about retraining models. I think the term we use is incremental learning, meaning that if your underlying model is a neural network model, and if you add new data to it and you get better results, you have to version it, because from a day-to-day basis, as Anna pointed out, you couldn't confuse the users by those borderline cases where you'll go yes from one day to no on another day, right? So the versioning is super important, not just from the user perspective, but from a regulatory perspective, if there is a medical claim to the AI tool performance.
Great. I mean, it sounds like that answer to recalibration mixes in monitoring. How do these monitoring systems look internally?
Maybe I can just jump in here. One of the things that we're trying to do is to do what we call model ops. So really is to look at how do you onboard and what's the process to onboard models that you have trained and you have retrained. So and from a model to model basis, how do you track the performance? And this is previously we've done this on the manual basis, where we retrain models on the same on the data sets prior and after, and we've seen the difference in performance, and then we validated it before we go live with it. I think there is a great opportunity here to do it in somewhat almost in real time with streaming data going forwards, and that's something that we are looking forward to see happen.
Great, thanks. Anna, any comments on that?
I think it's very similar sort of setups in every place. It sounds like he's set up is a bit more advanced, and we're just still building the sort of pipeline to deployment. But I think it's a similar plan. Yeah.
Sounds good. There's a question in the audience for you, Anna, which is, did the implementation of the staff planning model open the door or increase enthusiasm among end users for other tools? Or is it the same champions in general over time who are willing to lead these types of innovations?
I feel that it's some of the same champions. It seems that at least at our hospital, there are people that are just so far ahead with how much AI they want to implement and include, and that means both sort of the staff clinicians and heads of departments, and other places are just less prepared and are less ready. everybody's interested, but some more cautious than others, which means that it's the same champions that keep coming through. But I think once the pipeline is set up, there will be a more, and we will have a sort of a bottleneck for which projects go on. Then we will make sure that there is a greater diversity of the projects. But it's we basically never had to push clinicians or stakeholders or end users to deployment. They want it. They come to us when they want it, and they are doing everything to help us to have it deployed. So in some sense, we've been lucky, but in the other sense, these are the people that are more ready as well, and so sort of helps with a more successful duration of the project.
Could I just ask a question to Anna? You know, in terms of your projects, right? Where do you get the data sources from? Is this live stream data from throughout the hospital or beyond the hospital?
So it really depends on the projects. Sometimes it's not a lot of it is super live right now. There are sort of workarounds while we are building the proper live stream. We have set up the live stream for physiological data with the ICU, because ICU team has like several engineers dedicated to building something like that, and it's been really helpful and productive. Some of the EPIC data at our hospital is being prepared to go live, but we don't have any live stream. So that's being done through reports, like workbench reports and stuff. So it's not exactly real time, but sort of day old or Clarity, which is day old.
Yep.
So yeah, we are sort of building up to the real time for the EPIC data, but as you well know, this is a long and painful process. So.
Yes, I'm just gonna, yeah, commiserate with you on that point. Really, it's so hard to get the data out of Epic, and we are quite fortunate to have, you know, the whole of cluster, meaning that we have like 4 hospitals and like 6 polyclinics in our cluster. So we are going to get live stream data throughout all these organizations, and you know, it was so painful that to convince all the different sites to agree to it, but once they've agreed, then they understood, you know, now we can transact end-to-end patient journey care from specialist hospitals all the way to the community. And I think that is such a painful step, but such an essential step to ensure that your care continuity flows from one site to another.
That's you're absolutely right. And in terms of pediatric care, SickKids is the biggest children's hospital in Canada. So a lot of the smaller hospitals are looking to us to how we will build this. So we are looking to sort of share that knowledge, but all these communities are popping up, right? We now have a sort of working group with Great Ormond Street and Boston Children's and Royal Melbourne to sort of figure out the essential working streams and the data elements. So it's happening. It's just the beginning is slow.
Yeah, I agree with you. Yeah.
Building on that question about champions, Key, maybe you have some thoughts on like education for people who are medical doctors who are trying to understand more about the space.
Yeah, that's a great question. There's a lot of interest around data science in healthcare. So we thought of different approaches to doing this, and I think we've adopted the gradual build-up kind of approach where we've prepared a whole ladder of curriculum for our clinicians and non-clinicians as well, from everything from certification, so you learn skills-based or a high-level kind of understanding of what AI is and how it works, to things like you know, degree courses and executive education courses. So these are, you know, the exec education and the certification courses are really popular because, you know, it doesn't take up clinicians' time, and they get the kind of like, you know, a taste of what it is to build AI tools end to end. And some of them, I would say maybe about half of them would then engage in some kind of projects within their departments. And, you know, I agree with Anna, you know, the demand is always coming from the clinicians. It's not us trying to push them to do it. They are coming to us and saying that, hey, we really want to do this.
I have to second actually Key's point that there's a huge demand on courses, AI 101 in healthcare, this kind of thing. So our AI and medicine team also developed sort of one which is, full of pediatric examples and just given a sense of what AI is, what AI can and cannot do right now, how it works and things like that. And huge interest. Yeah, like these courses are usually full, and there are demands. Somebody hears at the hospital that hasn't seen the course and asking when it's happening again. So I feel there's a lot of drive to educate themselves and senior management, from senior management to staff clinicians to nurses. People are interested in learning.
Yeah, just a word of something that's interesting. But you can't learn Python in 2 weeks. That's obvious.
Yeah.
Last question that we'll have, we're about to end, which is from the audience. So somebody says that like clinical champions is necessary for adoption, but not sufficient. What do you do to ensure a higher likelihood of adoption down the road? Providing explanations is one example, but may not be enough to ensure success. Are there other things that are in mind? I know, Key, you mentioned a lot about explanations in your talk.
Yeah, maybe I just very quick point. I'm trying to convince my heads of departments to make quality improvement projects centered around AI, or make certain KPIs centered around AI, because a number of head of departments were very keen on this. It's just that they don't know how to motivate their staff to onboard, and the staff are motivated. It's just about telling them that, okay, this will be counted as your performance indicator.
Wow. I imagine there'll be a lot of resistance to that.
Yeah.
At least up front.
Absolutely. Yeah.
Yeah. I think the one thing that seems to make the projects to go to projects faster to deployment is alleviating the burden on the existing structure, like the IMT, the hospital IT is saying, well, do you need our people? Our people are really stretched. Like, what do we need for deployment? And figuring out the pathways to sort of say, no, actually, this is automated and this is automated, and here's the transparency. This is completely transparent process. This is exactly what happens, and giving it to review to the CSO, who is the chief security officer, and having a completely transparent process about what happens, how it happens, who is involved, who is affected, alleviates some of those fears at the sort of permission level. So this takes time, but again, we are in the beginning. But in terms of explanations, I view them as part of the development cycle, not deployment cycle. So together with the clinical champions, we sort of see and come up with what kind of explanations they need, and see what needs to be built in and why. So that it actually is interesting, because sometimes they don't ask for explanation. They say, as long as we know what to expect from the system, so we play with it and we see how it works. Some of the explanations are helpful and some are not, and some people ask for like a white box type model. So it varies a lot, but it seems that familiarity with the system and being engaged from the beginning sort of alleviates some of the explanation, but it's definitely part of the development cycle, not really the deployment cycle. Like, it can't come late. It has to be known what is needed upfront, because the models actually depend on that.
Super. All right, I want to thank the both of you. We've got to hand it off to our next session. It's wonderful. So next up, we have